This video talks about factorials and permutations, which is going to make the questions that we looked at yesterday using the fundamental counting principle a little bit easier, and it allows us to tackle more complicated problems. So the first thing that you need to know is, what does a factorial mean? It's the exclamation symbol on your calculator, and all it means is that you start with n, and you're going to multiply by the next number one below it. So times n minus 1, n minus 2, then times n minus 3. This continues all the way until you get down to the number 1. So for example, we're going to calculate each. So you can use your calculator for this. I'm just going to expand the first one so you can make that connection between the n factorial and the number factorial. 7 factorial is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. Use the factorial button on your calculator. This should give you 5,040. 11 factorial is the next one. Using the button on your calculator should give you 39,916,800. Okay. Now the next one, when you type this into your calculator, no problem, you get, let's see, 3,603,600, nice big number there. Now, if you try to type this one into your calculator right away, you're going to get an error. The numbers are too big. So then what we need to do is be able to simplify our fraction a little bit. So what I'm going to do is I'm going to write out the top factorial, and I'm going to stop when I get to 73 and write that as a factorial. So this numerator here is the same as 78 factorial. Now what this allows me to do is that I've got 73 factorial on the bottom, 73 factorial on the top. Those are just numbers, so I can cancel them out, leaving me with 5 numbers to multiply together, which is still a big number, but something that is small enough for my calculator to handle. So let's look at some permutation questions now where we're going to use factorials. So example 2 is a bit of a review from the fundamental counting principle. How many 5-letter arrangements can be made with the letters from the word Swift? So this is like the book question in the video 1.1 fundamental counting principle. So for the first letter, I've got 5 choices to choose from. Now that I've already used a letter, for my next spot, I've got 4, 3, 2, and then 1, which gives me 120. So these 120 represent permutations. So a permutation of n distinct items, so in our example 2, that would be the letters from the word Swift, is an arrangement of all the items in a linear order. So you're just lining them up. The notation that we use for this is NPR, which is a button on your calculator, or P bracket NR, which is equivalent to n factorial over n minus r factorial. NPR stands for the number of arrangements, number of R arrangements of n different objects. So in a permutation, there are n possible ways of choosing the first item, n minus 1 ways of choosing the second, n minus 2 ways of choosing the third, and so on. In our example above, with the letters for Swift, we are looking for a 5-object arrangement of 5 different objects. So if we were to solve this, we would have P, we've got our n objects, and our arrangements. That's how many letters we're looking to have the length of our strand be. So we can evaluate this as 5 factorial over 5 minus 5 factorial. This simplifies to 5 factorial over 0 factorial. Okay. Fun fact, 0 factorial is actually equal to 1. So this is just equal to 5 factorial. So therefore, if we're choosing n objects in n arrangements, our number of permutations is just n factorial, which is a special case. So let's do an example of using this notation. In how many ways can a class president and a vice president be chosen from a class of 28? So the number of people that you're choosing from, that is your N value, how many objects you have. Your R value is your number of positions that you are choosing, which in this case is 2. So what you are looking for is out of 28 people, how many ways can you choose 2 of them? I can write this in factorial notation as 28 factorial over 28 minus 2 factorial, which gives me 28 factorial over 26 factorial, which gives me 756 ways a class president and a vice president can be chosen. Let's do another example here. In how many ways can 8 horses place first, second, and third in a race? So my number of objects, which is N, is 8, and I've got 3 ways that I want to arrange them. So my R is 3. So my probability statement, or my number of permutations, would be N, R, and I would have 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial, which is going to give me 8 factorial divided by 5 factorial is going to give me 336 different ways 8 horses can place first, second, and third in a race. Another example here that comes up a lot is using letters. So how many arrangements of forest are possible? First question is if there are no restrictions. So I've got 6 letters and I want to make an arrangement that is 6 items long. So then my objects are 6 and my length is 6. So then I would just have 6 factorial is going to be the number of arrangements if there are no restrictions. So the next one asks me is if the R and the S are adjacent. So what we're going to do is consider RS to be one letter and take up one spot. So my first option is the arrangement where the R is before the S. And what I have now are 5 options to choose from because I'm considering R and S to be one letter. Out of 5 possible spots, I have a second option where the S comes before the R. And again, I have the same setup for my permutation. I've got 5 objects to choose from, considering SR to be one letter. 5 objects for 5 spots. So I can simplify this by saying 5 factorial plus 5 factorial is going to be 240. Something important to note is that 5 factorial plus 5 factorial is not equal to 10 factorial. Okay. Our last example here is what if the F has to appear first and the T has to appear last? So my first position is fixed, okay, which is an F, and my last position is fixed, which is a T. So then what I'm trying to decide is how many ways can I organize the middle 4. So what that tells me is that the number of permutations I'm looking for is 4 for N. I've got 4 letters left for 4 different spaces, which gives me 4 factorial, which is 24. So that means there are 24 ways where the F has to appear first and the T must appear last.